Welcome to E Squared Emporium for all things AP Psychology. Today we're going to talk about part 3 of learning and behaviorism. This part is cognitive learning. So we already talked about cognitive, that's thinking, but how do we use or express our thinking in our learning? So this is learning that involves mental processes such as attention and memory, and it may be learned through observation or imitation, and it may not involve external rewards. So we call this social learning theory. Newer terms call this social cognitive theory. You might see it as SCT. It's also known as observational learning. Basically, we learn socially by observing each other. So Albert Bandura in 1961, he says that learning takes place by watching another individual model whatever the task is. It could be a new dance. That's why we watch TikTok to learn new dances. It could be something at work. You watch a person make a sandwich and then you can copy how they made that sandwich. But his famous study where he proved this in 1961 was the Bobo doll study. So a Bobo doll looks like this clown that I have here, and it's made of plastic and it's usually got sand or water in the bottom. And you can punch it and it falls down and pops right back up again. So what they did is they took children, and some children watched an adult being very nice to the Bobo doll, doing very pleasant things with the Bobo doll, having a cup of tea with the Bobo doll. And then they took another group of children who watched adults hitting the Bobo doll, getting on top of the Bobo doll and punching him in the face and all, and throwing him around. Also, we should say that young girls watched grown women and young boys watched grown men, so it was gender similarity there. What he noticed was that the children who were exposed to the aggressive modeling adult caused the children to imitate that behavior. And in fact, the children got quite violent. The children pulled out a toy gun. The children actually expanded on the violence and they were cursing and saying very violent things. So, what he noticed, his conclusion is that learning happens also when we observe others and we model their behavior. And aggression can be learned for sure through observation. So, this has many important implications for humans. We see now negative effects of violent television programming, violent shooter video games, the potential positive effects also. So, children can learn positive things from their role models as well as negative things. So we learn positive pro-social behaviors like compassion, donating, helping, charity. We also learn negative antisocial behaviors like being mean, being prejudiced, bullying. And children tend to learn about fighting by watching their parents fight. It teaches us kind of our fighting style. So one example that was used in the early days for social learning theory has to do with television shows. And so in 2001, this young boy, Lionel Tate, who was 12 years old, he was watching the WWF wrestling and he practiced one of the moves. He was modeling the behavior that he was observing. It was observational learning from the television. And he jumped off the stairs and slammed onto a 6-year-old girl named Tiffany Unick and killed her instantly. And he was charged and tried and had to go to trial. And it was a very big deal for social learning theory. And so aggression is a learned social behavior through observation and the imitation of others, such as watching what's on TikTok nowadays or watching what's on television. So American children see over 10,000 different acts of violence on TV per year. And children act more aggressively after watching this violence. Children are more aggressive with strangers after watching this violence. They're more aggressive at school with classmates and friends. So we become habituated. That means we kind of become desensitized to all this violence. If you have seen 5 murders before the first commercial break, you're kind of desensitized to talking about murder and to seeing the sight of a gun and to seeing these acts of violence. We get very desensitized to it, and then it seems like it's normal. And there's a huge debate about violence in video games. So some people say that some of these video games teach violence and teach us to be more violent. And other people argue that they actually help us to release our violence, that it gives us a safe place to kind of channel some of that violence. So, in this Bobo doll study, the social learning theory study, his hypothesis was children who observe an adult behaving aggressively towards a Bobo doll will be more likely to imitate that aggressive behavior when given the opportunity. And so, with the groups of children, he also would add frustration to it. He would bring the children into a room where there were all these beautiful, amazing toys. And some of the children, he allowed them to stay in the room and play with the toys. But the ones that he wanted to frustrate, he would say, no, those toys aren't for you. And he would take them out of that room. So they were already getting frustrated and already getting aggressive. And then he showed them the modeling of the adults being aggressive with the Bobo doll. So the independent variable of this study was the behavior of the adult model. So one group saw the adult model aggressive behavior, and one group saw the adult model non-aggressive behavior, like having a cup of tea with the Bobo doll. And then the dependent variable was the child's aggressive behavior towards the Bobo doll, specifically the number of imitative aggressive acts they displayed. And as I said, they even got more creative than the adults. So here are the results that we see after Bandura's study. So children who observed aggression are more likely to imitate it. They're more likely to show new, unique forms of aggression, such as taking out the toy gun. They're more likely to transfer aggression into a new context, so bringing it to school, bringing it to other places. They are more likely to imitate behaviors they see in TV, cartoon, movies, TikTok. They're more likely to imitate aggression if the model was punished, and they're more likely to they're less likely to imitate aggression if the model was punished. That should say less likely. If the person who was doing the modeling was actually punished or scolded for doing the aggressive behavior, the adult, then they were less likely to follow that. But they were more likely to imitate the aggression if the model was rewarded or not punished at all. And he also noticed that boys were more likely to exhibit physical aggression than girls, probably due to testosterone and other biological factors. Although I will say the girls in their pretty dresses were pretty aggressive as well. So, how do mirror neurons play into social cognitive theory? So, brain cells, we know, are the basis for observational learning. We talked about mirror neurons already in the bio unit. So observation and imitation are facilitated by these mirror neurons. Remember that when we see somebody playing football, it activates the mirror neurons in our part of the brain that wants to play football. So just watching somebody hitting, shooting, stabbing activates that part of our brain as well as if we are also doing it. The same thing that if we see somebody eating, it activates the part of our brain as if we're also eating. So it allows the observer to mirror those actions, and this is great for empathy, but we also see this also works for aggression. So we call all of this vicarious conditioning. It is learning that occurs when you observe the actions and the consequences that another person gets. So you may change your own behavior based on what you see. So this involves imitating the behavior if the outcome was positive and avoiding that behavior if the outcomes were negative. So, for example, you see your older brother getting punished for borrowing the car without permission. Well, you have been vicariously conditioned not to borrow the car. You observe your friend get an award at school for their hard work, and you now have been vicariously conditioned that that's a way that you could get a reward. You see someone being bullied, and you're getting vicariously conditioned also. We also call this modeling. So you might see the term modeling being used kind of interchangeably with this social learning theory. So modeling is the process of learning new behaviors by observing and imitating others, right? So it's the same as observational learning. So, and it's also called social modeling. So we learn so many things by watching teachers, watching coaches, watching our parents, watching our family, and try to figure out what is the appropriate thing to do and how do you do it. So there are four elements of observational learning, and the learner plays a much more active role in the learning process, just like with operant conditioning. So the first stage is attention. The learner pays attention in order to observe the modeled behavior. So if you're not even watching, if you're looking at your phone and you don't even see the fight happening, you're not paying attention, right? In the animal world, animals watch the alpha animal. Like when the alpha horse is being trained, all the other horses in the field stop and watch them. They want to see that behavior being modeled by the alpha lead. So you have to be paying attention in order to pick up the observational learning. Then there's retention, which has to do with our memory. So the learner mentally represents and retains. We have to retain what we observed. So someone can show you how to ride a mountain bike, but if you weren't paying attention and you're not retaining what they're saying, then you didn't get observational learning. It's not going to stick. Reproduction has to do with reproducing, right? Can we reproduce the results? This may depend on our physical abilities. Maybe we're not as good, we're not as adept as that person was. We haven't learned all those skills yet, but we're going to try. We're going to try to do our closest, best estimate of what that was. We're going to try to reproduce it. And then motivation is the last one, but it also ties into reinforcement and reward. So we are motivated either to perform that behavior because that got the person a bonus, it got them food, it got them a reward or an award, it got them something, it got them attention, it got them a relationship, it got them something that we wanted. So we're motivated, and that's our reinforcer, right? The reward. We also could be motivated at that point to not do the behavior based on if we saw punishment happening there. So again, here's the process in just a different format. Attention, we're watching the aggressive behavior and it has our attention. Then retention, did we hold it in our memory so that we could repeat it? Reproduction is the repeating it. Can we physically perform the behavior and repeat it? And then motivation, are we more or less motivated to imitate that behavior? Did we see something positive happen or did we see something not positive happen? Jumping into another type of cognitive learning, insight learning, Wolfgang Kohler studied the cognitive learning of apes, and he noticed that there was insight, this sudden awareness to solve a problem. So he had chimps in Germany at his Kohler Institute, and he gave them various tools, and they had to figure out all on their own how to solve the problems, and there wasn't trial and error. He noticed that they solved them suddenly, not gradually, not let me try this, let me try that, like we saw with Thorndike's cats in the puzzle box. He saw that these non human animals were capable of a flash of inspiration. There was all of a sudden, just from all of a sudden, they understood instantly how to put the pieces together. So, one example was his famous chimp named Sultan. So, Sultan had to take a short stick that was in his cage and use it to reach a longer stick that was outside of his cage. And then he had to put both sticks together and make a really long pole. And then he was able to pull bananas from outside the cage into the cage and get the reward that he wanted. And all of that seemed to come to him via insight. So that's insight learning. So here's some other examples again at his Institute for Chimps. The monkeys learned how to add water in order to lift items. They learned how to manipulate crates in order to reach what they wanted. So all kinds of tools were provided so that they could show their insight, and usually food was used as the reward. Edward Tolman also used cognitive learning. He was about cognitive mapping, and he used rats to find their way through a maze. So he realized that the rats were creating and storing cognitive maps in their mind. And they were able to pull up these maps whenever they were needed. So here's how he did it. He would let the rats run through the maze, and then he would eventually start blocking their pathway. And so he would force the rats to find alternate routes. So the rats had to have a spatial memory of what the entire map looked like, and they don't have GPS and they didn't have Google Maps, but they had to be able in their mind to find a similar path, an alternate route if he blocked their path to get the reward or to get the exit. So he hypothesized that if the rats had formed cognitive maps, then they could navigate the maze using the new path instead of just memorizing a sequence of movements, right? So it's not just, oh, we memorized this and we're just going to keep following it. That way is blocked. I have to find a new way. Let me go to my cognitive map in my brain and figure out a new way out. So his cognitive map experiments in the 1940s, they profoundly changed the way that we think about animal research, but also cognitive psychology and memory and spatial navigation systems in our mind and in our body. So the research aimed to explore how animals, specifically rats, but we also can apply this to humans, how they map their environment mentally and how they use these cognitive maps to navigate almost as if they could see from up above, almost as if they could see from space or from a GPS, but they don't have that. By examining the findings, we gain insight into spatial memory and how that works, and various learning processes and other cognitive functions. And it really does apply to humans as well. So, cognitive maps also exist in our minds, and it's an unconscious memorizing signal from the physical environment. You remember where to turn. You could be in the middle of a conversation and you don't even know the name of the street, but you remember that you turn at the gas station. You turn at this landmark. You remember maybe that the street sign looked like this, or you have these things that you remember. So you don't have to know all the details necessarily. And what if your road is blocked? What if there's a tree down and you have to find a different way home? Well, hopefully you learn after you've driven around a little bit, you learn that there's another way into that development, or you learn there's another way to get there. We have multiple alternate routes to get places. And if you didn't have your GPS and you didn't have MapQuest and you didn't have any other devices, you would still be able to eventually navigate your way. So firefighters actually use these cognitive maps in their brain. They will walk through buildings. Have you ever wondered why they walk through your school? They will walk through buildings. They will drive their service route so that they are ready to go, so that in the event of a fire, they know exactly where to park, where to stop, who is where, how many floors are in the building. They have an approximative cognitive map because they have already walked through your space. They have already walked through your building. Tolman also used the same studies for what he called latent learning. So sometimes he didn't reward the rats. Sometimes the rats were just learning in the absence of a reward. There was no reinforcement. So the rats wandered in a maze for 10 days and received no rewards or punishment. On the 11th day, the food was placed at the end of the maze. And at that point, the rats were quickly able to find the fastest path to the food, the fastest path out, showing that latent learning had occurred during all their time spent living in the maze. So, what does this look like for humans and for animals? This means latent means hidden. It means it's not seen, it's not easy to tell. So, this is a behavior that we've acquired, but you don't really have to show it off until you need to, right? Until you really need to demonstrate it. And then all of a sudden, oh, yeah, I do know how to do that. I do know how to drive. I do know how to do that. But until you're really put to the test, it just kind of sits there in the background, kind of as a hidden cognitive learning tool. And so once the rats were given the reward, boy, they could solve it very quickly. So they have known how to do it all along. They just didn't really have the motivation to do it quickly. And how many times are we the same way, right? We could get the project done or get the chore done or get the job done pretty quickly, but until there's a reward dangled in front of us, we don't really have the motivation to do it very quickly. So sometimes our learning is not immediately evident, and sometimes we need a reason to display what we've learned. We need the pressure of a quiz or a test or a project. We need the pressure of our friends in the car with us, watching us driving. We need the pressure of a race, which with our competitive school, the school that we're always rivaling, and we need that sometimes to show our latent learning. And now you are ready for class.